Hey guys, welcome to another video. So today, another question in the nice series videos. So today's question comes from the advanced syllabus. Now, it's a nice question today. It comes from the Balcombe Hills 2024 trial paper. It's the last question, right? It's 2 marks and it's in the topic of integration. So now, really nice question. In fact, when you see the question, for those that know a little bit about Extension 2 4-unit maths, it looks like a 4-unit question, but last question of Balcombe Hills advanced paper. So now, before we dive right in, if you haven't already done so, please like the video, subscribe to the channel, and tell your friends. All right, now let's dive right in. So last question in Balcombe Hills. Can I just say, Balcombe Hills past papers are generally quite hard. So this question being the last question of its paper for 2 marks, and it's a pure integration question. I mean, you've got to give it a bit of respect, right? You look at this question now. Normally with a 2-unit advanced integration question, it's either very textbook or it lends itself to like one of the integrals given in the reference paper. Like the most common one when you see a fraction like this would be like to maybe, try to let the bottom be fx, right? Don't do this because like you'd fail. And then once you do that, you try to see whether it's like, if I differentiated that pink expression, whether it give me the derivative on top for the ln integral to work, right? In this case, it doesn't, right? If you did that, you'd waste some time doing algebra and realize that you failed. Now, I must admit, when I first saw this question, I had a dabble in differentiating it. It didn't work, right? So this guy here is not the way forward. Instead, right? The way forward for this, right? The way forward for this is to basically use a bit of algebra and rearrange some things first. So firstly, see how it's like x3 on 2 plus 5x, factorize x out, all right? And that becomes what? X power of a half plus 5 dx, right? Now, I'm just going to use some indices to make this work. So basically, every time you see a power of a half, so every time you see a square root, make a power of half. And so I'm going to do 2 things, right? 1, I'm going to remove the root x outside, and 2, I'm going to replace all the square roots with powers of a half. So I want it to look a little bit like this. So that becomes x. Bring that x outside, that becomes square root on its own right. And then that becomes like x power of a half plus 5 power of a half as well, right? So okay so far, algebraically? Now, so at this point, right, it still feels a bit difficult, right? Bring both powers upstairs, right? So make it into a negative power as such, right? Negative power. And then at this stage, if you can recognize it, right, guys, this is a function, right? Let this be your function. And for those that remember, I mean, the derivative of this pink part, now the 5 goes away, derivative of square roots is going to have like a square root on the bottom, which is this, right? So at this point, you can go, if this is fx, then f dash x is equal to, now when I differentiate, for those that remember, differentiating that, x power half, bring down the half, minus 1 to the power, right? Now, this is already there. So then to make this guy use a reverse chain rule, right? I need f dash x there. I need to introduce a 2 there, right? And then bring out a half to make it integratable, right? So then this whole expression now can be integrated using the reverse chain rule, right? Where all I got to do is say to myself, okay, there's a half in front, take the bracket, add 1 to the power, divide by that new power. Yeah, divide by that new, yep, add 1 to the power, divide by that new power. Now, sorry, I'm just looking at the answers. Because, yeah, that should work. Let's just see. Oops, I did a little bit of a mistake over here because that's half there. I put 2 there, so this really should be the other way around. So let me just correct for that. So this should be a half over here to make it the same as the derivative, and so that should be 1.5, which is 2. So remove this guy, that should be 2. And then last but not least, guys, bring that upstairs to multiply with this guy. Then you get therefore 4x half plus 5 power a half plus c. Or you can do, right, to make it look a bit nicer, 4 root x plus 5 if you want to. Guys, very nice question, very quick. Hopefully that was okay. I mean, when I saw it, it just felt 4-unit, right? But in the 2-unit syllabus, that's a hard question and a nice one. Guys, let's leave it there. Like the video, subscribe to the channel, and I'll see you at the next one. Thank you.